Hello everyone. Let's start with a simple thought. Have you ever sat in a car that moved at a steady pace on a straight road? The speed feels smooth and unchanging. That's what we call uniform motion. Velocity remains constant with time. But now think about city traffic. One moment you're speeding up, the next you're slowing down. Here, the velocity keeps changing with time. This is non-uniform motion. Physics asks, how quickly is the velocity changing? And the answer to that question gives us today's concept, the rate of change of velocity. So how do we measure this rate of change? We call it acceleration. Mathematically, acceleration equals change in velocity divided by time taken. Or in symbols, A equals open bracket V minus U close bracket divided by T, where U is the initial velocity, V is the final velocity, and T is the time interval. The C unit is meter per second squared. This means every second, the velocity changes by a certain number of meters per second. Now, acceleration can be positive or negative. If your velocity increases in the same direction as your motion, like pressing the accelerator pedal, that's positive acceleration. But if you apply brakes, your velocity decreases. This is negative acceleration, also called retardation. Both are measured in the same units, but the sign makes the difference. So next time you feel that jerk when the bus slows down suddenly, you're actually experiencing negative acceleration. Acceleration too can be uniform or non-uniform. In uniform acceleration, the velocity changes equally in equal intervals of time. A perfect example is a body falling freely under gravity. It gains about 9.8 meters per second every second. In non-uniform acceleration, the velocity changes unevenly. Imagine a car on a bumpy road, speeding up and slowing down irregularly. If we plot velocity against time, uniform acceleration gives us a straight line, while non-uniform gives us a curve. Let's calculate acceleration step by step with a real example. Case 1. Rahul starts from rest, so initial velocity U equals 0. He reaches a final velocity V of 6 meters per second in 30 seconds. Substituting in the formula, A equals open bracket 6 minus 0 close bracket divided by 30. That gives 0.2 meters per second squared. Positive acceleration. Case 2. Rahul now applies brakes, slowing down from 6 to 4 meters per second in 5 seconds. Substituting, A equals open bracket 4 minus 6 close bracket divided by 5. That gives minus 0.4 meters per second squared. Negative acceleration. So the same bicycle ride shows both speeding up and slowing down, two faces of acceleration. Acceleration is everywhere around us. Drop a ball, it accelerates uniformly downward due to gravity. Watch a train steadily increasing speed on the tracks, uniform acceleration again. But ride a bicycle on a hilly road, the pedaling, slowing, and speeding makes it non-uniform. And every time a car or bus brakes to stop at a signal, you feel negative acceleration. So acceleration is not just about going faster, it's about every kind of change in velocity, faster, slower, or irregular. So to sum up, acceleration is the rate of change of velocity with respect to time. It is given by the formula A equals open bracket V minus U close bracket divided by T, and its unit is meter per second squared. Acceleration can be positive or negative, uniform or non-uniform. From falling objects to braking cars, from trains to cyclists, these examples bring the concept alive in daily life. This understanding of acceleration builds the foundation for our next step, the equations of motion, where distance, velocity, acceleration, and time come together beautifully. I hope you enjoyed this session. See you next time with another exciting piece of physics.